Welcome to Python's virtual environment session. Let us look at the outline of this session. We will explore the motivations behind creation of virtual environment, then understand what is virtual environment, followed by steps to create virtual environment. In the end, I'll provide an illustration to show that installation of packages in one virtual environment will not impact the other virtual environment. Let us move on to the motivations for virtual environment. Assume that you are given a very simple task of creating a dashboard. In that dashboard, you'll enter a stock symbol of a particular company. Once you enter the stock symbol, you will display certain charts that constitutes the details of quarterly stock prices, stock returns, sales, profits, and revenues, expenses of this particular company. Your job is simply read the data set from the Bloomberg, clean this data, visualize as per the project requirements given. Say you accomplish this project in October, November 2022. Your dashboard looks something beautiful like this. Now, let's try to understand how you accomplished this job. You created a test server. On this test server, you have a technology stack where you installed Python 3.7. Within this Python 3.7, you installed two packages. First package is Pandas version 1.5. This package is used for reading the data from Bloomberg database and at the same time clean the data and prepare the data for visualization. For visualization, you have Matplotlib 3.6.1 version, which is primarily used for creating different plots and graphs. In this process of cleaning the data and visualization, you use certain functions like data frame, lookup, and others for visualization. Let's keep that in mind. You accomplish this with a single test server and production server. Say in May 2023, your client came back to you and gave you new requirements. Hey, along with the details that you're displaying as a part of dashboard, why don't you add debt as well as working capital of that company and ensure that it's visualized for last 4 quarters. Given these requirements, which are fresh, what is your strategy to incorporate this new requirement into the existing production code? Say in that process, you reviewed the technology stack again in May 2023. You found that Python is upgraded to a new version 3.11.3. The Pandas package is available with new features, Pandas 2.01, and Matplotlib is also upgraded to Matplotlib 3.7.0. So, in order to incorporate enhancements, will you continue to code in this old technology stack or will you upgrade your technology stack? What is the decision that you're going to make? This decision is not very simple because when you look at the documentation of Pandas 2.01, you find that the lookup function you used earlier is no longer available in Pandas 2.0. Packages continue to evolve over a period of 3 to 6 months, and it is important to track the functions that you are using and whether they are continuing with the new versions or are they being deprecated. If the function that you are using in your previous code is deprecated, any upgrade in this scenario would break your application. If you're upgrading to Pandas 2.01, your code will break in test server as well as in the production. So now what's the solution? One standard solution is upgrade the technology stack on test server, rework on any code breaks if some of the methods are deprecated. In that case, you can ensure that fixes are done, add the new requirements in your application, test it thoroughly on test server, and then move it to the production server. This works very well only if you have one project with one upgrade. What if you have multiple projects and many teams working on it with multiple upgrades as well as multiple releases? In that scenario, the other option is to create a single server for each project. In this case, assume that there are 3 projects. Each project is supported with a server. On each server, you made package upgrades. After making the package upgrades, you added the new requirements. After adding the new requirements, you tested thoroughly and pushed the code to production server. This looks like a perfect solution, but the challenge is it is expensive. If you have 10 projects, you have to have 10 servers, which is complex in terms of maintaining the project, and at the same time the cost for the company would increase if you add each test server for each of this project. So we need to figure out what is the right scenario here. Python's virtual environment solves this problem for us. Key motivation for the Python's virtual environment is it enables you to handle many projects and many package upgrades in each of those projects. At the same time, ensures that you can actually protect that virtual environment against unwarranted upgrades. That's quite vital, and it has been found useful by lot of developers, and therefore they continue to use this concept of virtual environment across the projects, whether you are developing web application or data sciences project or data engineering. It has become a standard to use virtual environment. Next, it is cost effective for a simple reason that you can create multiple virtual environments for your projects on same computer or same server. It doesn't require additional infrastructure. It is a very easy to understand and implement, therefore empowering you to control your projects completely. Now let's look at more internal details of Python's virtual environment. Before going into more details, let's keep it in mind that pip is a command used to install as well as upgrade packages from Python package index. Every time you need to upgrade or install a package, use this pip command. Now let's come back to understanding Python's virtual environment. Python's virtual environment is a directory. Assume that each project is a virtual environment. So you create a separate directory. This directory structure is designed in such a way that it protects this entire directory from installing packages or interfering with the packages in other virtual environments or other project directories. A folder site packages will contain all the packages installed in that particular virtual environment. There are many advantages with Python's virtual environment. In the next slide, we will look at the advantages of virtual environment using an illustration. Let's go back to the requirements in November 2022. During that period, you had a technology stack of Python 3.70. Say you created a virtual environment where the interpreter in bin directory is Python's version 3.7. There is a side dash packages directory that contains pandas 1.5 and matplotlib 361. Using these packages and the interpreter, you wrote the Python code to meet the requirements and saved in this .py file. You deployed the entire virtual environment to the production. The advantage of deploying this entire virtual environment to the production is that the code remains with the packages as well as the Python interpreter. As a result, the business logic written in this .py file can be replicated in any server. Therefore, it ensures reproducibility. Now, let's move to May 2023. In May 2023, you realized that the tech stack needs to be upgraded. You first installed new version of Python interpreter. After that, created a virtual environment. After creating virtual environment, your interpreter in the bin directory is 3.11.3 Python version. Next, you installed latest versions of pandas package and matplotlib package found in site packages directory. Here, use this November 22 Python file for the dashboard requirements. Ensure that all the code breaks are fixed due to new package releases. Then added the new requirements for the dashboard in May 2023, and you saved this file as stock dashboard May 2023.py. After testing it rigorously, you can port this entire virtual environment into the production environment so that the business logic will not be disturbed, leading to the reproducibility of the business logic.